So what I thought I'd do is I'd just talk a little bit about a particular study that I'm interested in, which is focused on asthma. The talk is split into these sections. I'm going to talk a little bit about asthma and why it's a really complicated disease and why we need new medicines. Talk a little bit about asthma as a genetic disease. A little bit about the approaches that we're using to map genes, and really focus to why UK Biobank is an absolute fabulous opportunity for us in this research area. And then I'll end by talking a little bit about where we're going with this type of research. So I'm sure you're all aware that asthma is an incredibly big problem. 100 to 150 people worldwide have asthma. That equates to 5.5 million in the UK alone are actually taking medication for asthma. 1.1 million children, 4.3 million adults. And again, quite a sobering statistic is that every 17 minutes a child is admitted to hospital in the UK because of their asthma. And also, if you think about economic burden for the UK, we're talking about 1 billion per year to the NHS, really focused on asthma treatment and costs. And again, it's important to note that asthma, there's no cure for asthma available, and there's only treatments that treat symptoms and manage those symptoms. And really, we need new medicines for asthma. As I mentioned, asthma is a complicated disease. It presents in different ways. The typical symptoms are wheeze and breathlessness, and airway obstruction. And it's really quite a horrible disease, to be fair. Also, airway inflammation, so inflammation occurs in the airways. And what we've found, previous data, is that asthma really is about genetics, but also about the environment. So it's those two combinations that lead to the development of asthma. Also, it's quite important, it makes it a challenge from a genetic point of view, is that asthma is really heterogeneous. So different asthma patients present quite differently, and we think have quite different underlying mechanisms that drive their disease. So on this slide, just to add to some of what I've described about symptoms, but if you look inside the lung of an asthma patient, it's incredibly different. So on the left is a normal individual. As you can see, this is the airway, and this is a cross-section of an airway, so the airway tube, basically. And if you look at the right, it's incredibly different. There's excessive inflammation, there's lots of airway smooth muscle bundles. So essentially, it's morphologically, or it's very different to a normal individual. And we really don't understand in detail how this comes about. And we think genetics might be able to understand some of these mechanisms that lead to this structural change in the airways leading to asthma. Don't really worry about the details on this slide, but this is a little bit about how asthma is currently managed or treated. So the approach is a stepwise approach. So a person comes to the GP, they get diagnosed with asthma, and they're given an inhaler as the first step of treatment. And really that medication is increased in a stepwise manner to try and manage that person's asthma and control that person's asthma. And keep stepping up through things, reaching ultimately things like oral steroids, high doses. And then when asthma is maintained or controlled, it is then stepped down. And this is the current management of asthma at the moment. What's quite important to say on this slide is that this stepwise management of asthma, once you start reaching the higher steps, there are patients that really don't get any benefit from existing drugs. And these are the more severe or refractory asthma subjects, which is one of the particular areas that my research is interested in. So I think you'll see that there is a need for new medicines, particularly for those severe patients that don't really get good benefit from existing medications. And we're talking about 3 to 10% of patients with asthma have severe asthma. Treatment options are limited, even on very high doses of steroids, for example. And what we think is that severe asthma may have different mechanisms. So part of my research is to try and understand those mechanisms that drive that disease. And we think genetics is quite important in that driving. So UK Biobank is a fabulous opportunity to start prizing out some of those genetic changes. If we think about genetics and how it works, we've had a nice talk earlier about risk and predisposition in a way. What's shown on this slide is why asthma is particularly a challenge. So we have diseases that are considered simple diseases, even though they're relatively complex, things like cystic fibrosis, where there's a very big genetic effect, and therefore mapping genes is a little bit easier. The problem with diseases such as asthma is there is like I mentioned earlier, there is a genetic predisposition, but then it depends what you see in the environment. That double hit then leads to the asthma presentation. And those things could be things like smoking or virus infection in the lungs, air pollution, for example, and of course allergens, and we know asthma and allergy are related. We've touched on this slide earlier. It's a complicated slide, but what this relates to is the parcels we talked about earlier, genetic parcels that span the entire genome. And for all intents and purposes, our human genome is a string of letters. We all have our own string of letters that's unique. And what is different about those letters is that some of those letters change our genes and regulate those genes. And these are the things that cause disease ultimately. So shown in the middle of this slide is actually a string of bases or letters, and in the middle is a genetic change. And this is really what we measure predominantly in our genetic studies. This is the parcel that we measured, 800,000 of them across the genome, to see which parcels go with the disease. This is a typical type of design that we use in genetics. So we have people with asthma, and we have people that don't have asthma. And basically we look at their genes and their genetic changes and see if genetic changes are more common in those people that have asthma compared to those people that don't have asthma. And we do this many, many times across the whole genome. And this helps us identify genetic changes that might be risk factors for the development of the disease, asthma. We've seen one of these plots before. This is the Manhattan plot, named after New York City, of course. And the spike basically tells us that there might be a genetic change in that region that might be important for asthma. And so this is the type of thing we're hoping to get out of our study, actually, when we complete. And this is an early study in asthma showing that many genes across the whole genome might be important in asthma. And it's very small changes in many different genes that we think cause asthma. So now taking a little bit of a step back. So I've been involved in a large collection of asthma subjects, patients from across the UK, the Genetics of Asthma Severity and Phenotypes Initiative. And so what we've been doing is recruiting patients predominantly from hospital settings, and particularly patients that have severe disease, because we think in particular this is a really unmet clinical need. And this is where we are at the moment. This picture really shows that we've collected all across the UK and also in Northern Ireland, 16 centres, and we've collected around 4,000 subjects. And about 3,000 of those people have a moderate to severe disease, so the severe end that I mentioned earlier. So why is UK Biobank really important for our study? It's a fabulous resource, 500,000 people, as been mentioned before, but the key thing for us is the clinical information is really comprehensive, and also slowly becoming available is the genetic information. And in particular to my study, using the asthma patients that I've just described that we've collected across the UK, of course UK Biobank has been collected across the UK as well. So genetically, our patients are very similar to UK Biobank participants. Also, really important to flag is that within that 500,000 people of UK Biobank, about 60,000 people have asthma. So it's a really important opportunity to look at asthma genetics just within UK Biobank as well. And also what's been touched on previously is that genetic changes across our patients and also UK Biobank have been measured in exactly the same way using the same technology, which is really important in genetics, so that we can now combine all of that resource, our own and also UK Biobank. This is how we plan to use UK Biobank data in a case control design that I mentioned earlier, so where we take people with asthma and without asthma and compare their genetics. And this is the strategy we're about to do, actually. We're just at this late phase. So where we'll take our moderate to severe asthma patients and we'll compare them to control subjects from UK Biobank. These are people that do not have asthma, do not have allergies, and do not have respiratory disease. And there's rare resources in the world that you can pull the types of numbers that actually can exclude those confounders in this type of analysis. We'll do this in a discovery setting to identify new genetic differences. And then, as mentioned again earlier, replication or repeating those types of tests to show that it's a true result. We'll do that also using biobank samples as well. Again, this time asthma patients from the biobank and also controls. Also, as part of this study, we were very keen, and a secondary objective is to compare mild asthma to moderate severe asthma. As I mentioned, mild asthma is generally quite well managed using current medicines. And what we really like to see is what's different about mild versus severe asthma. And again, there's an opportunity in this study to answer those questions from a genetic perspective. So where are we now? We have all of the genetic information, and we're finalising some quality checks on that data. From our own study, we have about 2,500 asthma patients available for this analysis. And we've started using the really rich UK Biobank data. And at the moment, we have access to 150,000 UK Biobank data sets. And what we found is that when we use our checks to exclude things like respiratory disease, allergies, we've got about 97,000 people that we can use as controls for our study and also in the main analysis. We've also found that in the 150,000 people that we have data for now, about 18,000 of those individuals have an asthma diagnosis. And that again opens up opportunities of how we can further delve into asthma and also stratify asthma, which is what we're doing at the moment to identify those moderate severe subjects in that 18,000. So the next stage is, it's important to say, is that through the fantastic opportunity of UK Biobank, this will actually be the greatest and largest study of moderate to severe asthma in the world. There's no studies that have used these types of numbers before. And so there's a really nice opportunity to get something novel and really interesting to really help us understand severe asthma. Again, we'll look at mild and moderate severe asthma, and again, we're hoping to see potentially something different there. And then also, again, very large numbers, there's a really opportunity to find novel genetic things underlying asthma per se by combining all of our data and UK Biobank data. So what do we hope to get out of this? Really, we hope to identify novel genetic risks that basically predispose you to develop asthma. And in particular, as I mentioned, try and home in on moderate severe asthma that's really not very well managed with medicines at the moment. And why is this important? It's really important because this gives us a potential opportunity to identify new mechanisms and new things that drive the disease. And only by understanding the disease in more detail can we really develop new drug targets and new medicines. So it's fundamentally important. So just to come towards the end. So again, just to reiterate, it's really important to say thank you to all the participants of UK Biobank. Our study would not happen without the free time that's being given to this. And also our asthma patients are being recruited across the UK. I'm stood here by myself, but of course I have a massive team behind me that are involved in this study, particularly in Nottingham with other researchers and Ian as well, and also in Leicester and particularly the genetic epidemiology group or analysis group. And then the other people listed on these slides are scientists and clinicians that have collected the samples from across the whole UK and made this this study actually viable. And again, Asthma UK, I want to say a special thanks to that funded part of my study, and AirProm have also been involved, which is a funding consortium as well. Okay, so I'll leave it there for now, and I'll open it to any questions.
Thank you.